Week 9, we're going to do it's a two-part lecture. First part is very short, user preps and saving default state, and then we're going to be doing some core animation today, which is actually a really interesting, fun topic. And then on Thursday, we'll talk about performance and optimization and debugging.
Okay, so like Glenn said, I'm going to have a rather lightning-fast lecture on user defaults and saving state. So we'll just talk about that really quickly, and then we'll do the first bonus lecture. Historically, core animation has been a really popular one of those, so I'm going to do that today because that's really popular and everybody likes core animation. As you'll see, it's actually really fun and easy to do animation on iOS and Mac. But first, we'll talk about saving state. So on iOS, as you've probably seen if you play with any iOS app, the user is never expected to explicitly save on iOS. The assumption is that the application is constantly saving for the user. It kind of saves automatically. So that way, the user can, as soon as they leave the app and come back to it later, that they can come back to right exactly where they were and not have to load a file in to get started. They can just immediately be back right where they were. That used to be a little hard. iOS 4 made that incredibly easy. The iOS already just suspends your process and then brings it right back to where it was. So there's actually almost nothing you have to do to keep track of basic application state. It's also worth noting that a lot of these same principles apply to Mac OS X now that Lion has a notion of auto-saving. And again, there's an expectation that applications, especially document-based applications, should be able to save your document constantly and just be able to save automatically. And especially if you want your Lion app to be able to have versions, to use the versions feature, it has to be able to support auto-saving because those features are really one and the same. So typically, at least on iOS, you really only need to save state basically right before you're about to quit, since iOS 4, the application goes into the background state. So some useful methods here. Application will terminate. This method has been around since iOS 1, I assume. That gets called when the home button gets pressed. Since iOS 4, rather than if your application supports background being placed in the background rather than iOS 3 or earlier style where it just immediately quits, which by default all new applications that you create by default support background suspension. The methods that get called instead are did enter background and will enter background, did enter background and will resign active. Will resign active is when your application is no longer is about to become the non-active application, and then did enter background is actually after it's gone into the background. So these are kind of the logical places in your app delegate to know when you're about to be quit. And so if you have any data that you absolutely have to have saved, so that way you can remember where the user was next time the application launches, this is a good time to actually fire off that saving code. Yeah?
Does that work for power off situations?
That's a good question. I would imagine that if your application is open and then the user decides to do a power down, I would imagine that it calls. I haven't tried that. I imagine it will call one of these.
Actually, I'm not sure since it essentially freezes in place. Okay, I'm not going to say anything.
That's kind of an edge case. I don't know. You'd have to ask the internet for that. I would like to think that it would call quit on all your applications, but it might not. Okay, any other questions? Okay, so if you have a relatively small amount of data that you need to store, and this is on the order of 10K or smaller, basically, kind of in that ballpark, there's a really simple tool that's available on Mac and iOS called NSUser Defaults. It's typically used for storing things like user settings and preferences. So if you have a skin on your a choice of skins for your application, you want to be able to save what the user's favorite skin is that they're using right now. Things like that kind of thing, like user default, like login information. User defaults is a great place to save those. It's kind of this. The idea is it's basically a dictionary that you can write to and read from, and it's preserved across launches of your application. So it's basically a dictionary that's directly on the hard disk that you can read to and write from across calls to your runs of your application. So that will be preserved even if on iOS 4 or later that you minus the process in the process manager. It's saved across applications. The only time it gets erased is if you totally delete your application and reset your device. I've even seen cases where if you delete the application, then reinstall it, the defaults are still there. So the only way to really absolutely get rid of it is to do a restore, as far as I can tell. But the idea is that it's basically a dictionary that you can read to and write from. And so the way you get it is you ask the NSUserDefaults class for the standard defaults. So that's the singleton. So each application has a single instance of NSUserDefaults. Standard defaults gets the user defaults for your application. Then you just write to and read to it like it's a dictionary. So here in our did finish launching, so this gets called when our application first launches. We can so we can check if we already have a value in our defaults, and if it is, then we can load that default. Otherwise, we would generate some basic default, I guess. And then, for example, when we're about to go into the background, we can set objects in this user defaults dictionary. So to save them across calls. One nice thing about user defaults is, as you've probably seen with regular NS dictionaries, all the members of the dictionaries must be actual subclasses of NS object. NSUserDefaults provides a number of methods like setInt value and setFloatValue that will automatically box that thing up in an object for you before writing it out to the dictionary. So you don't have to do that boxing yourself. There is just, if you want to store an integer value for next time, you can just say standard default setInt, and then you assign a key for it. So again, it's just like a dictionary. It has keys and values, and it's saved across runs every application. Does anybody have any questions about user defaults? Like I said, because it's just a dictionary, it's pretty easy to understand how it works. The one thing you have to be careful about, though, is these set object calls or replace object or remove object calls. They don't immediately go out to disk. There's kind of a temporary user defaults dictionary object that lives in memory that you're writing into and reading from for efficiency reasons. If you actually want to commit those files or those changes out to the actual dictionary that's stored on the hard disk, you want to call synchronize on it so that way it flushes those changes out to the dictionary and guarantees that those changes that you've made have been propagated and will be saved. Otherwise, if you don't call synchronize, then those changes aren't guaranteed to be saved. But other than that, it works basically just exactly like a dictionary.
How often do you have to call synchronize?
Typically, you just need to call it once. So you can make a whole bunch of changes, and then typically you just need to call it anytime you make a change. Then at the end, before you return from that method, you just call synchronize. I think if you leave off of synchronize, they may get committed to disk, but synchronize will force them to actually get committed. So it's a good idea to always have a synchronize after you do a bunch of sets or replaces or deletes. Yeah, I don't think you need to call it a whole bunch of times, because that's because it actually does go out to the disk, which even though it's an SSD is relatively fast, it's still very slow compared to memory operations. So you don't want to use it a lot. And that's especially important in things like didn't or background. So these delegate methods on UI application, actually iOS puts a timer on them. There's a daemon process running on iOS called the watchdog that basically ensures that things like quitting and booting up don't take too long. And if they do, then it will just immediately kill your process. So you want to make sure that these enter and exit methods are as fast as possible, because otherwise, if you have something that takes 5 minutes to launch, Watchdog will kill it. The timeout is usually on the order of about 5 seconds. Yeah.
So this is stored on hard disk?
Yeah. So the user defaults is actually stored in a file within your application sandbox on the actual flash memory drive on the device.
Okay, and it does get flushed every single time you load it.
Yeah, and so when you actually invoke synchronize, then it will actually write those changes out to the file on disk.
I mean, like, say you were debugging with an iOS device, and you change your program settings, it's not going to be the same user interface.
No, it will be, which if you're, I've found in my experience of working with user defaults that because of the fact that it persists so well, it actually can be a problem when you're debugging. If you've written the data out to it that you don't want, then it's kind of stuck there. So when if I do anything with user defaults, I do as much of it as possible in the simulator, because the simulator is really inexpensive to just wipe it, and because if you go to the simulator menu, there's a reset all content and settings that will wipe it, and that will guarantee that old user defaults is not there. But yeah, I think what you're asking is if I run an application, if I run an instance of an application and I write to user defaults and then I make changes to my code and then rerun it, that defaults is still there. So definitely something to watch out for if you're writing an application that uses defaults. That dictionary will persist across runs, and if you want it to be deleted, then you should, in the simulator, you should restore your device to the original settings, and that will wipe the file out.
It's also really common to put versions too in your preferences and your defaults. So you can. That's one of the first things your app can do is read in the version, and you can just keep bumping it up by one each time. And if it's old, then you can wipe it out with fresh defaults.
Yeah, so that's a pretty common thing. If you want your application to show to do automatic version counting, so you can keep track of how many times you built your application. You can make a little defaults file or a preference file, and then just increment a little counter every time. And then, but again, unless you delete the file, then it's just going to just keep going up. Okay, so another way to store state is using what are called property lists. Again, these are meant for fairly small data sets. Again, on the order of several kilobytes, but not much more. These, under the hood, NSUserDefaults actually uses property lists, and the idea is that they're just XML data that you can serialize and unserialize to store objects out to file. And so what can be contained in a property list, and this goes for user defaults as well, it can contain arrays, dictionaries, strings, numbers, dates, and data. And it's worth noting that the root element of a property list is going to either be an array or a dictionary, nothing else. So even if you want to store just a number in a property list, it must be a member of an array or a dictionary. But the idea is it's a way to take an array or dictionary and write it out to file, or take a dictionary, an array that's in a file and read it in and actually generate Cocoa objects from that file. So there are two convenience methods on NSArray and NSDictionary. There's write to file and write to URL, and then there's similarly read from file, read from URL, and then also like init with contents of file and init with contents of URL. And so what's really cool about this is you can actually write to a URL on the internet. So if you have a file, some server that you have write access to, you can actually write to that URL using this request. iOS also uses under the hood URLs to do local directory paths. So if you have some arbitrarily complicated directory structure within your application sandbox, you can use NSURLs to path through that directory structure. But the idea is that the path of the URL should represent, or the string or the URL should represent the path to the file they want to write to. There's the reason there's this. Shoot, what is atomically for?
Atomically?
I think
it can't be interrupted.
That's what it is. So atomically, it just means if it's yes, it means it cannot be interrupted, which means it will do the entire write at once. If anybody else tries to read while there's a write, it won't. It will just stall until that write is complete. So useful if you have a multi-threaded application and you want to make sure that if you have multiple writes that they go in sequence. Okay, and then if you have bigger data sets that you want to store, you can also use SQLite. The entire SQLite API is available in Cocoa and Cocoa Touch. Again, that's just, if you're familiar with SQL, that's just a C library, that's just a set of C functions that allow you to manipulate SQL databases. There's also, as we'll talk about sometime soon, depending on when you guys want to hear about it, is Core Data, which is Apple's alternative to using tools like SQL to store relational data sets. So we'll talk about that later in a little bit more detail, but Core Data is really great for fairly large data sets to store a lot of data out to file. Okay, any questions about saving state and user defaults? If not, then I'm going to go on to the really fun core animation lecture. Okay, so now I'm going to talk about core animation, which is the framework for doing animation and various compositing effects on Mac and iOS. Core animation defines a notion of a layer. They call it of class CA layer. And the idea is layers are very similar to views. They work almost the same. There's a hierarchy of layers, so each layer has a single parent layer. It has potentially many sub-layers, and they're drawn from back to front, so that way that the thing furthest back gets obscured by things that are drawn further forward. And like views, they specify their geometry relative to their super layer, so just like they all have a frame rectangle and a bounds rectangle, just like views do. So there's actually, as we'll see, there's actually a one-to-one mapping between views and layers. Every view contains a layer, and layers have to be placed in views to be placed on screen. So typically, you don't have to worry about the details of layers. Typically, if you have a view, you have a layer to go with it, and you can draw into that layer. One cool thing about layers that you don't get with views is that layers allow much more complex geometry. So views if you've seen, I don't think you guys have seen yet, but one cool thing about views is that you can actually apply what are called affine transformations to views, and these allow you to perform a lot of various morphing of a view's bounding rectangle, but they're limited to what are called affine transformations, which are transformations that preserve the parallelness of opposite sides. Layers, on the other hand, allow much more complex geometry, they basically allow you to do much more 3D geometry, where you have rotations and skewing and weird scaling effects and shears and projection effects, which you can't do with views. Like I said, views, the only transformations you can apply to views are affine transformations. Layers you can apply arbitrary transformations to. So layer geometry is more or less the same as views. It's a bit more complicated. Unlike views, the frame is more implicit than with a view. The way you specify where a view lives in its parent view is you give it a frame, and that defines exactly where it lives in its parent view. Layers are a bit more complicated because the way they define it is there's this slightly odd notion of the position, which is roughly speaking the center point, but it doesn't actually have to be the center point. It can be shifted away from the center of the rectangle. But the frame is computed from the position, the bounds rectangle, which again is just basically a width and a height to specify the internal geometry. This anchor point, which is the anchor point. If you want to rotate a view, by default the anchor point is in the center. So if you do a rotation, it just kind of rotates about the center. The anchor point is the point around which you rotate when you perform rotations. So if you want to rotate from the corner, you can put the anchor point in the corner, and then when you apply a rotation, it will pivot around that corner instead. And then lastly, if there's any transformations that are applied to the geometry, and again, these can be arbitrary three-dimensional transformations, that also defines what the frame rectangle of the layer is. If you decide to mess with the anchor point, be aware that uses unit coordinates, which means that the lower left corner is 0, 0, the upper right corner is 1, 1, or that's on Mac. On iOS, it would be inverted. But so 0, 0, 0.5, 0.5 would be the center, for example. Okay, so like we mentioned, we can perform pretty arbitrarily complex transformations on layers. There's a C structure, CA transform 3D, which is a 4x4 matrix that represents a three-dimensional transformation on that view. So if you've taken 184, you're probably pretty familiar with these kinds of 4x4 matrices that represent all these arbitrary transformations. I'm not going to go into much detail about those. That's what the documentation is for. They have a lot of explanation about how to apply transformations, how to do these really cool 3D perspective effects, and you can do these all with these with these matrix transforms. And then you just assign a transform to your layer, and it gets drawn with that transformation applied. One really cool thing about layers that you can do is there are certain properties about the layer, like its position, its opacity, its transform, and a whole bunch of others that are designated as being animatable. And what's really cool about them is if you change the value, it animates the change automatically. If you have a layer and you change a property, it just animates it. It's really pretty spiffy. As you'll see, I'm gonna do a demo app later that you'll see it's almost a trivial amount of code to do animation. So this is what's called implicit animation. So again, suppose we have a layer, and if we reassign its position to be 500 500 instead of 100 100, and we can change its opacity to 0, so it will move from 100 100 to 500 500, and it will fade to 0 opacity. You can also do things like messing with the opacity to set it to 1, and it will fade it in. And as long as this is a layer, it will it will automatically animate using some default timer for the animation. I believe the default time is 1/4 of a second. There are ways for you to configure the timer, and these can be done with explicit animations, which are rather complicated ways to. But they're rather complicated, but you have a lot of finesse over how you want the things to animate. So you can set the duration of the animation. You can set how many times you want it to repeat. So if you want it to go back and forth several times, you can have it repeat. If it auto-reverses, so if you have a movement that goes from point A to point B, it will auto-reverse. It will just go from point A to B to point A to point B to point B and back and forth until you hit repeat count or something. And then you specify basically a from value and to value, so the value you want it to start at, the value you want it to end at, and then you add an animation for a key, and then you give it like the key of the property that you want to change. So you can set, for example, the opacity key, and again, the documentation explains pretty well how to determine what key you want to set. So I won't go into that, but even this is fairly complicated. If you don't really need the fine-grained control of doing everything at the layer level, which often you don't. Most of the time, you can do all the animation you want by just manipulating views. And views, like layers, also have certain properties that can be animated. And with just a few extra lines of code, we can actually make those properties animated. So this is actually slightly outdated. I'll talk about in a bit the newer way to do this. But there's a whole slew of class methods on UI view that allow you to define blocks of animation. So the two key ones are begin animations and commit animations, and basically anything between a begin animations call and a commit animations call, any changes to any animatable properties done between those two calls will be animated. You can also, before you actually do anything, you can set a number of properties on that animation. So the time you want it to start at, if you want to have a delay or set the duration or change. The animation curve will determine how fast it moves relative to the time of the animation. So if you want it to start really fast and then end really slow, there's a curve for that. If you want it to start really fast or slow and then end really fast, to kind of speed up as it goes. If you want it to start slow, kind of do a sine curve and start slow, be fast, and then slow at the end, there's a curve for that. This is hard to explain with just listing all these functions because there's a lot. So hopefully the demo will make this a lot clearer. Okay, so I'm going to make a really simple view application. I'm going to call it Stalker. We'll see why. Take your time, Xcode. Oh, well, that doesn't fit. I guess I'm going to use iPhone then. Oh my god, I hate doing this. So small. And I have to give credit to Alan Canestraro, who taught the iPhone class several years ago at Stanford, and this is almost exactly his demo. Alright, so I'm going to add a little view to my window here. I'm going to make it blue. Okay, so now let's go to our view controller. And let's add an outlet to that view. Go ahead and hook it up. little stalker. Okay, so now let's get rid of all of this. I don't really need it. Also, let's make this bigger for everybody. Okay, so I'm gonna override touches began, and I'm gonna get out the thing. I'm expecting only one touch, so I'm gonna get out the touch. Just asking any object for its touch, then I can get its point. Okay, and now all I'm going to do for now is just say stalker.center is that location. So now every time I touch down on the screen, it's going to move the stalker to that location. Oh, not the iPad. No, stop. Oh, good. Now we get to wait for the simulator to launch. Come on. Okay, so this should not be too exciting. Every time I click, the little stalker follows my tap and moves to exactly where it is. Okay. Now, are you guys ready to have your minds blown? Because I'm going to make it animate with 2 lines of code. UI view, begin animations. I'm just going to, it takes a string, it's just kind of an identifier for the animation block, so that way if you have more than one, they stack correctly. And then I commit those animations. Done. And so now that defines an animation block, which means that everything in between the begin animations and commit animations will be animated. Okay, so that's all well and fine. Let's have some fun with that animation and do a little customization of it. So one thing we can do is set the animation duration, so we can have it take a very long time. Have it can take 2 seconds. Oh, well, that's kind of weird. You notice how it started to animate, then I tapped somewhere else, and it jumped to where the first animation was going to land. That's maybe not the best thing, but we can actually change that. There's another configuration we can do that we can set animation begins from current state, which says that even if another animation is in flight, it will stop that animation right where it is and then go from that exact position. So now if I tap down here and then there, it stops the first animation and continues right from where that animation started. Okay, so let's have this go back to a fairly reasonable time so I can show you something else. So you notice, it may be a little hard to see, but you'll notice that that animation is rather slow in the beginning, slow at the end, and fast in the middle, so there's kind of this sine wave of the speed of the animation. If we would like to have it start out slow and end fast, we can change the animation curve. And so there are 4 different curves. There's ease in out, ease out, and linear. So linear is pretty obvious. It just goes the same speed throughout the entire animation. Ease in is it starts slow and ends fast. Ease out is it... No, do I have that backwards? I think I have that backwards. I think ease in is it starts fast and ends slow. Ease in out is it starts slow, goes fast, then ends slow. And then ease out is it starts slow and ends fast. I might have that backwards. That's one way to find out. So ease out is it starts fast and ends slow, and then ease in will be it starts slow and ends fast. But we what's kind of cool about views is there's a lot more that we can configure to have animate than just its location. So if we wanted to have it turn a random amount of transparency, we can also animate that. So we can say, I don't know, random mod 100 divide by 100. So that'll just give me a random float between 0 and 1. And that one, and then we'll set that to be the opacity of the view. And so now every time it moves, it chooses some, a little hard to see, but it's some random transparency. We can also change the color. I believe that's also animatable. Stalker.background color. Unfortunately, there's no random color, which would be kind of nice. But let's just say we'll see this the first time. Anyway, so we'll transition from blue to red, and so there's a wide variety of these things that you can change. You can imagine having it, in addition to move, you can also have it scale down to a certain width and height, and it will animate all those very smoothly. Any questions about this? Okay, so that's how that was done until iOS 4. iOS 4 introduced a few new ways to do animation, but before I talk about that, there's an Objective-C language construct that's been introduced since the same time called blocks. This is actually a C language feature, I think, that Apple introduced. It's part of the Clang compiler, and I think GCC can do it too. But it's this really cool runtime feature that is they're rather like functions, but in addition to just having their own local variables and input variables, blocks can also capture variable bindings from its the current stack and heap at the time that the block is created. So in that sense, they're pretty much full closures. If you're familiar with what a closure is. And they're often used as callbacks, and a lot of the built-in API functions that Apple provides expect as input one of the parameters to be a block. So that way, the idea is that you can just specify a block of code to be called whenever the function wants to call it. And so an example, as we'll see with animation, rather than having a bunch of UI view configure calls, and then a bunch of property changes, and then a commit. The idea is you can take all of those property changes, put them in a block, and then pass them to a UI view animation method, and it will call that block to determine what gets changed in the animation. So this here is a very simple example of an Objective-C block. The syntax is very, very strange looking. It's still hard for me to get it right a lot of the time. So the way you declare a block is you first declare the return type of the block. So again, it's like a function, it has a return type. And then in parentheses, beginning with a caret, you declare the name of the variable that represents the block. So if you're familiar with C function pointers, this looks almost the same, except that they replace the asterisk with a caret. After the first set of parentheses with the variable name in it, you have a comma-separated list of types, but just the types, not the types with the variable names, just the types, and those are the inputs to the block. And so that whole part there to the left of the equal sign is the type declaration for a block that takes in an int and returns an int. Then what we're assigning to the variable myBlock is a literal block, and so the declaration of a literal block, again, you start with a caret to indicate I'm declaring a block, then a parenthesized list of parameters, and here you do include the types, or the names as well. So this takes in, as input, an integer, we're going to call it num. And then within curly braces, the body of the block. In this case, we're just returning num times multiplier. But notice the multiplier isn't defined in the block, and it's not one of the parameters. It's actually able to grab the value of multiplier from the state of the stack at the time that the block is created. And so now once you have a block, you call it just like it's a function. So here we have a variable. Again, we have this myBlock variable. It takes in as input an integer and returns an integer. So we call it like it's an integer function, and then it gets returned an integer. Any questions? Besides the syntax, which is really weird. Does that make sense to everybody? I guarantee you'll get the syntax wrong at least once. I do it all the time. It gets especially funky when you define functions or methods that take blocks in as input, because then you have to declare the type of it correctly, and it gets kind of strange. Yeah?
So there are similarities between Objective-C and Ruby on Rails, and so Ruby on Rails also has iterators and AD closures like this as well. Does Objective-C also have iterators?
Yeah, there's an Objective-C class called NSEnumerator that many objects define for being able to loop through the elements of that class. And if you want to explicitly do enumeration that way, you can do it like that. A lot of the built-in classes, like arrays and dictionaries, do the newer fast enumeration style. So that's how you're allowed to do like for x in this dictionary, and that's been available since I want to say Leopard, but before then everything was done with enumerators. So it's kind of the concept certainly exists. And if you want to define your own, you're certainly able to do that. Okay, so, I have little bits for all the pieces. Okay, just as a review then, start with the return type. Then a caret in parentheses followed by the name of the variable for the block. Then a parenthesized list of types. Then the actual literal block definition. Okay, so blocks don't have to be declared as variables. If you just want a little temporary, basically like a lambda, you can do that. You can do that as well. So here we have an array of strings with some people's names in it. There's a library function qsortb that performs quicksort on two C arrays, and it takes as its last input a block, which is the function that it uses to do comparison. And so we've defined a block here. The qsortb expects the inputs to be just two void stars, so it's a point. That's, if you're not a C person, that's a pointer to anything. It takes in as input two pointers, which is why we need to cast them down here to actually, so that we know that they're actually character arrays. And then in this case, we're just performing store comp on the first character. So then the way qsortb works is it uses that block to do each comparison operation when performing the sort, and then afterward that array is now sorted. But you can see that we haven't declared like a variable for this block. We've just placed it inline within the function call, which you're allowed to do. I prefer not to do that because the tabbing tends to get really strange. If you it gets really weird, especially if you try to inline a block into an Objective-C method call, because then, especially if there's more parameters after the block, then it's really odd to see what lines up with what. So I tend not to do inline blocks just because it's easier to read, but you can. Okay, so since after the development of blocks, Apple introduced a number of even better ways to do a lot of things on Cocoa and Cocoa Touch, including animation. So an example method is animate with duration animations. So it takes in as its first input the amount of time you want the animation to run, and as its second input a block that defines all the properties you want to change during the animation. There are also versions for animate with duration. Animation's completion is the same, except it takes an additional block that they term a completion handler that gets called after the animation is completed. So if you need to do something only when the animation is done, you can pass a completion block, and it will get called when the animation finishes. Then there's another one that also takes in a delay and a bunch of options, so that way you can again configure all of those things, like the animation curve, for example. Yeah, and so this is the one you. This is kind of the super method it takes. It works on all of them. As you can see, declaring the type of a block inside of a function, inside of a method, is a little bit strange. That's just how it works. You kind of have to get used to it. But again, so it takes in the duration of the animation, the initial delay for before it fires, then it takes a bit mask of all the options you want to set for that animation. If you don't want any animations, you can just pass 0 for that. And then it takes a block for the animation. So an animation block is really simple. It returns nothing, it takes in nothing. So if you want to define a literal animation block, you can just do caret, curly brace, stuff, close curly brace. And that's an animation block. The completion block takes in a Boolean for finished. I think they have that in case that the animation gets canceled. It will pass completion with no rather than yes to say that the animation got canceled rather than actually fully completed. So if you need to know that the animation actually completed, you can test the value of finished. Okay, so here are all of those options that you can configure again. Again, like I said, the third parameter here is just a bit mask, so you can just bitwise OR all the options together that you want. So there's things like begin from current state, repeat, auto reverse, you know, which animation curve you want. There's another really neat thing. If you have a view that you want to replace with another view, but you want that view, you want that change to be animated. So this is fairly common. You can imagine, like on iPod, where when you tap the little button on the upper right, it flips to the back of the album. There's an animation where if you replace, for example, the image in an image view, it can flip to animate. It can flip to animate that transition. So there's several animations that transition styles that you can configure for that. Okay, so now let's redo that stalker example, but with the new style of blocks. So I'm just going to hide all that. All right, so the first thing I'm going to do is I'm going to define a block for the animations that I want to perform. So the type declaration, so it's a void. It doesn't return anything. I'm going to call it an animate block. It doesn't take in anything. It doesn't take in anything, and then inside of the block I put the things I want, the changes I want to have animated. So we can say stalker.center equals location, and now if I want to animate this, I can say UI view animate with duration and quarter second, and then I just pass it that animation block. So now, as I move it around, as I click him around, it animates it. And I'll leave it to you guys to figure out how to. What?
Sometimes when it terminates the application on your behalf, it interprets it as a crash and takes you to main, which is where the crash happened.
Thank you, Xcode. Okay, so I'll leave it to you guys to figure out how to do the rest of it. But it's pretty easy. You can just call one of those additional animation methods that have more parameters to set the different properties on it. So any questions? Okay, so that's all I have. Just some resources for you. The first one is the rather large guide to programming with core animation. So if you want some more details about how to use core animation to do custom things with animation and compositing layers and that kind of thing, that's your resource. If you like working with blocks and you think that's a cool idea, or if you're struggling with them, there's a link for how to write blocks and what blocks are used for. And then lastly, the UI view class reference will have all of those animation stuff in them. I think there's a rather large section in the class reference about animating views and working with animation in views. So that's a good source for that too. Okay, any questions? Okay, cool. So there's no new lab today. So you guys are free to start working on your projects or something, or ask us for ideas, or if your idea is good, or that kind of thing.